Good morning to the respected teachers and my dear friends. I would like to welcome our esteemed guest of honor, T. Pushpalata, MCA PhD, and head of the MCA department. She has 12 years of teaching experience and published 7 papers in national and international journals. Also published a book titled Cybersecurity. She has been awarded 2 intellectual property rights and most influential women in academics. Consequently, twice, that is 2019 and 2020. I feel privileged to welcome you, ma'am.
Thank you, girls. Am I audible?
Yes, ma'am.
Yes, ma'am, you're audible. You'll start the session, no?
Yes. I hope they have given topic related for the cluster analysis. This is the one of the important topic in the data mining. Many students have the idea about all the concepts related for the data mining. What are the trending keywords in the present scenario? Tell me some of the keywords. Data science, right? Data mining, machine learning, deep learning, artificial intelligence, right? These are the main terms with the most buzz, right? Data mining is the generally it is the one of the part of the data science only. The world is getting smarter every day and keep up with consumer expectations. Almost all the companies also increasing using the machine learning algorithms to make all the things are easier. Now I'll give a simple example. Through face recognition only for unlocking of smartphones. Nowadays, everyone is using these end user device, right? Not only this one, we are detecting credit card frauds. Immediately, how they will detect the credit card frauds here? When any kind of the triggering alerts comes, immediately they will react. Now, within the artificial intelligence and machine learning, or maybe the data mining, we are using 2 basic approaches. Am I audible, girls?
Yes.
Yes. What are those approaches here? One is the supervised learning and second one is the unsupervised learning, right? And I will giving the first 5 minutes briefing of overall topics. Then only I will come to the cluster analysis concepts, right? Tell me what is the supervised learning? It is also one kind of the approach defined by its use of the labeled databases. What are the examples for the supervised learning here? Already you covered the topics in the earlier units. One is the classification and second one is the regression, right? Within the classification also, if you can identify the problem by using of the algorithm, you can categorize all the objects by giving of the labels, right? And second one is the unsupervised learning. This is also another approach within the machine learning algorithm or maybe the data mining algorithm to analyze and unlabeled data sets. That is the difference between the supervised and unsupervised learning concepts. Now we are discussing about unsupervised learning. What are the main tasks or models are there within unsupervised learning concepts? First one is the clustering. Second one is the association. Third one is the dimensionality reduction. These are the 3 different kinds of the task we are performing within the unsupervised learning concepts. Now we have to giving the briefing of cluster analysis, right? Generally, what is the meaning of clustering? First, I'll show the example. Within the example, how many colors are there within the screen? Tell me what are the colors? Yes? Mass thing about
Yellow,
the
yellow, red,
red,
blue,
blue,
green,
green,
and violet.
violet. Right? We can easily identify these, we call it as this is a space, open space, right? On the top of the space, we have the different kinds of the objects, data objects. We are treating each and every color shape, we call it as a data objects, right? And now by using of the classification, we are labeling on the bottom. We can observe that under the top, that is the blue color. In the blue color means automatically what are the objects related for the blue color, it will be placed within the particular data sets. Next we can go for the red color data points. Automatically we have to collect all the red color data points and we are keeping. These are all things are possible by using of the classification, but within the clustering there is no labels, right? That's why this how can you identify without labels? Clustering is one of the data mining technique for grouping of unlabeled data based on their similarities and differences. We can easily identify what is the similar features are there between two objects. Here we can see that if you can compare these two data points, my arrow is moving, right? We can easily identify that this color is yellow, this color is red. Automatically, these two objects are different. Some dissimilarity is there between these two objects. Automatically, we can say that this is another cluster, and we can call it as these are all the red color data points as another clusters. If you can observe here, this yellow, this data point is yellow. Another near data points we can identify with the same color. Automatically we can say that this is all the data points related for the one cluster, right? Finally, how many clusters we are forming without unlabels? We can check the similarity and dissimilarity between the data objects. Easily we can make it as a cluster. Now how to form the cluster here? Here I can make it as all the blue data points as a one cluster, yellow as a one cluster, red as a one cluster, green as a one cluster, and next one is the blue as a one cluster, violet as a one cluster. Total how many clusters here? 1, 2, 3, 4, 5. Here no labels. Just we are identifying what is the similarity and dissimilarity between the object. Based on the similarity and dissimilarity, we can identify, we are grouping all the data objects. It's clear? Now here we have to see that what is the cluster analysis. Cluster means collection of data objects. That means we have to pick all the data objects together as a one group. How can you collect all these data objects? Based on two keywords. One is the similarity, second one is the unsimilarity. Based on this similarity and dissimilarity between the objects, we can make it as different kinds of the groups. And next one is the cluster analysis here. Automatical analysis means we are doing the analysis on the top of any kind of the data sets, and we are checking the what are the characteristics on the particular group of elements, right? For example, if you can see that within your classroom also, how can you identify the students related for MSc data science or the BSc data science? You're having the hall ticket number. Based on the hall ticket number, based on the hall ticket number, or you're having the code. Based on the code only, this is one of the characteristic of the student. Code only, it will giving the clarity about the student is related for so and so section or maybe the group. That's why here also we are finding the similarities between the data according to the characteristics found in the data and grouping similar data objects into clusters. Now, what method we are using here? Unsupervised learning, not supervised learning. Supervised learning can be used by the classification and regression. Unsupervised learning can be used by the clustering and association analysis, right? Within the what is the main feature of unsupervised learning here? There is no predefined classes. Based on the observation, we can identify what is the similarity and dissimilarity on the group of object. Then only we can make it as a different kinds of the clusters. Next one, clustering for understanding of application. Generally, everywhere we are using the clustering concepts. Here they have to given what are those here? Biology, land use, marketing, city planning, earthquake studies, and next one is the climate and economic search. Anywhere we can identify the grouping of any kind of the objects. Depends on the similarity and dissimilarity. We can make it as a clustering concept, right? And here we can observe that next slide. First, I have to give it as what are the main requirements are needed for the clustering. The first quality of requirement of clustering is interpretability. The result of clustering should be usable, understandable, interpretable, right? And next one is when I'm seeing the particular space, we can easily categorize all the objects into the different kinds of the clusters. The main intention for the clustering is it helps in dealing with messed up data, right? Already all the data, not only structured data, we have to concentrate only on the unstructured data. Those data is messed up. That's why we can't analyze quickly. That's why in such a situation, we can use the clustering. And next one is that we have to make the grouping depends on the similarity of the data objects. Either we can use it as a similarity or maybe the dissimilarity. Okay. Next one is the main reason for the clustering concept introduced in the data mining, high dimensional. And next one is the attribute shapes clusters are discovered. Already we have the different kinds of the shapes for the particular objects.
Hello, hello, ma'am. Hello.
Yes. Yes.
Ma'am, your voice is not too clear, ma'am. In between, it's like breaking.
It's breaking.
Yes, ma'am.
From the beginning onwards or now only?
From beginning, ma'am.
Maybe internet issue only.
Yes, ma'am.
Will be connected. Now it is okay. Yes.
Yes, ma'am.
What are the points are covered till now? Anyone can please tell me? Yes. Yes, girls. Am I audible, girls?
Yes, ma'am.
Yes, ma'am.
Okay. Just now I have to give it the clarity for the supervised and unsupervised learning, right? And next one is what is the meaning of cluster analysis. And just now I started what are the requirements are needed for framing of the clusters, right? Main thing is main intention for the cluster is it will be helps in dealing with the messed up data and unstructured data. And next one is the high dimensional. It will be handling all the data clustering algorithms, is able to handle the data of high dimension along with the data of small size. And next one is the arbitrary shape clusters are discovered. Now it is okay, girls?
Yes, ma'am.
Yes.
Okay. Okay, fine, girls. Types of shapes within the data mining. Do you know the shapes of data mining? Arbitrary shapes, spherical shapes, non-spherical shape, right? We have the different kinds of the shapes. So we have to frame the different kinds of the clusters. All these shapes we are introduced are discovered within the cluster concept only. And clustering scalability also is one of the reason for generating of particular clustering concept. And next I have to start what are the measurements are needed for improving of the quality of the clustering. Just now I have to discuss similarity and dissimilarity of the objects. How to calculate the similarity and dissimilarity between objects means by using of distance function. I know everyone knows what is the meaning of distance function. If you have the two different objects are there on the particular space, we can check that how much distance between two objects by using of different kinds of the distance functions are there. I hope you know that Hamming distance, Euclidean distance, and next one is the cosine similarity, Manhattan distance. These are the different kinds of the distance formulas you are applied for calculating the distance between any two objects. Not only objects, the objects may be the Boolean objects or categorical objects, ordinal and vector variables. I hope all the girls knows what are the types of different kinds of the data types are available within the data mining, right? One is the Boolean, second one is the categorical, ordinal, and next one is the vector variables. That means the object may be the categorical, the object may be the Boolean, the object may be the ordinal, the object may be the vector, right? And next one is the based on the distance only, we have to frame the clusters. So the example later examples. Next one is the quality of the clustering. Automatically, if you have to perform different kinds of the distance algorithm, we can easily frame the cluster. Automatically, it will improvising the goodness of the clusters. Either we can use the similarity or maybe the dissimilarity. Now, what are the considerations for the clustering analysis? We have the so many considerations are there. One is the partitioning criteria. We have the group of elements are there. Compulsory, we should divide the clusters means we have to partition. We have to divide it, right? That means we have to frame the group of elements or the group of objects. If you want to partition means compulsory, we should do the separations, right? And next one is how to do the separation by using of the similarity measures. After finding of similarity of the different kinds of the objects by using of the distance functions, automatically we have to frame the clusters on the arbitrary shape. And next one is the I have to give it as explanation for the what are the major clustering approaches. This is very important thing. Actually, we have the so many approaches are there, but within your syllabus you are having only the 3 or 4 approaches. First one is the partitioning approach. Second one is the hierarchical approach. Third one is the density-based approach. Fourth one is the grid-based, model-based, frequent pattern-based, user-defined, constraint-based, link-based clusterings are there. But we are giving the most priority for the clustering approaches are partitioning, hierarchical, density, grid. These are the 4 approaches are very important for framing of the clusters, or it will be playing the main role for framing of the clusters. What is the partitioning approach? Partitioning means we have to identify the mean value. Based on the mean value only, we have to partition all the objects into different kinds of the clusters. C1, cluster 1, cluster 2, cluster 3, cluster 4. Okay. And here we are giving the input as the data instances. We have to convert it into the disjoint spherical clusters. Next, we can go for the hierarchical. Everyone knows what is the meaning of hierarchical. It will be just like a tree structure. We can take it one node one by one, and we have to do the connectivity between the data objects. And next one is the density-based methods. Actually, here a density means how to calculate the density. It will completely dependent on the neighbors. Okay. Based on the neighbors, we have to identify the density. We have to apply the density function, and we have to connect. We have to calculate what are the minimum points are needed to frame the clusters. These are all the different kinds of the methods is there within the different kinds of the approaches. Okay. Grid-based means multi-level granularity structure. We have the different kinds of the methods are there. Model-based, frequent pattern based. I hope everyone knows what is the frequent pattern based pattern analysis. Which item is frequently appeared within the particular data set? We have to frame it as that is the one cluster. A regular student, regular who are present for. That means frequently visiting the college. That means we have to make it as a who are having the 80% of attendance, who are having the 70%. We can easily make it as a clusters. Depends on the frequency, right? Next one is a constraint based. The constraint means we have to apply the different kinds of the conditions on the clustering. Once the condition is satisfied, automatically we have to frame it. Will cluster 1 having one constraint, cluster 2 having the one constraint, and cluster 3 having the one constraint. Any object comes in front of the clusters, automatically the cluster checks whether the condition is satisfied by the so and so object. Immediately the object is placed within the clusters. That is the constraint based. Link based clustering. Either we can go for the different kinds of the linkages. We have to frame the clusters, either minimum and maximum or average grouping. We have the different kinds of the methods we can use it by using of the link based clustering. Okay, what is the first one here? That is the partitional clustering. The partitional clustering is the main important approach within the clustering concept. What is the main intention here? Any clustering approach, it will be separate what are the similar objects are there within the particular clusters. The main intention for the partitioning methods or maybe the partitioning clustering approaches, what are the algorithms we are using? Based on the algorithms, we have to partition the overall input data objects into disjoint spherical clusters, right? I have the one application. Based on the application, we have to represent the cluster by using of the prototype. And how to frame this prototype? We have to check the similarity, right? If you have the similarity is there within the object, automatically we have to frame the clusters. Here we can observe that the partitional clustering algorithm divides the n object. I don't know how many objects are there within the particular data set. Number of objects I'm divided into the clay clusters. The K may be there 2 clusters or the 3 clusters or the 4 clusters. It depends on the size. It depends on the nature. What is either similarity or maybe the dissimilarity, right? What we are doing here, randomly we are choosing any one of the k-mean value. Based on the k-mean value only we are framing of the clusters. I'll show the example in the further slides. Yes. In the partitioning algorithm, the main important algorithm is the k-mean algorithm. Actually, k-mean, first we have to identify any one data object as a mean value. Based on the mean value, we can identify that which points are near to the particular mean value, and we have to make it as a clusters. That is the k-mean algorithm. Okay, and next one is the we have to check that this is the algorithm steps. Once you can observe that we have the only 5 steps are there. Within the steps, first select k points as the initial centroids. I don't know how many points are there within the space. That's why I have to mention select k equal 10 points or 20 points or the 30 points. And we have to repeat third and fourth steps until the particular cluster is not changing. Form k clusters by assigning all the points to the closest centroid. We are choosing the centroid. That is the centroid, we call it as a mean value, which I think surrounded by, I am choosing one point randomly. I am choosing any one point as a centroid or the mean value. What are the all the points surrounded by the particular centroid? Any point is closest to the centroid, automatically those closest to points surrounded by the centroid, we have to make it as a clusters, right? Again, we have to go for the next centroid and we have to recompute what are the centroids for the each clusters. The screen is visible. What is the example is there on the screen? Yes?
Yes, ma'am.
Okay. Observe that what I'm telling, we have the, what is the meaning of k-mean algorithm? First, you can take the number of objects or maybe that number of data points, right? And next one is the from the data points we can take any one of the data point as a mean value, right? For the data point, for the mean value, we have to find out all the surrounded nearest points. We have to make it as we have to put it in a cluster. This one will repeat a number of times without changing of the same mean value. And next one is here we can observe that I have to take in some of the data. 1, 2, 3, 4, 5, 6, 7, 8, 9. Total 9 points are there, right? And I'm framing, I'm beginning, I'm taking as a initial clusters. That is your wish. The K value is how many clusters you are ready to take. Either 2 clusters or the 3 clusters or the 4 clusters. Here data points are very less. That's why here it will be taken as only 2 clusters, right? Out of these 2 clusters, I have to take any 2 mean values. That is your wish. We can take it as a 4, we can take it as a 6, any 2 mean values out of the total number for framing of the cluster. How many clusters you are ready to frame? 2 clusters. 2 clusters means you need 2 different mean values, right? That's why 2 mean values we should take from the overall data points from the data set, right? That's why random any one of the data point, right? Here, what are the data points I have taken here? One data point is 4, second data point is 12, right? These are the 2 mean points, mean are centroids for the overall data set, right? Now, how many clusters I framed? 2 clusters. Initially, I have to choose an K1, comma K2 are the 2 clusters. Automatically, K1, what is the first mean value? 4. Which are the points near to K1? We have to place it with the cluster 1. Which are the points are near to the 12? We can make it, we have to place it within the cluster 2. Okay. First, we have to start it from the first data point. 2, 4. Yes. 2 is near to 4, closer to 4 or 12. Automatically, 4 is very closer. That's why I have to place to 2 in the first cluster. And next we can go for the 4. Automatically the 4 is same value. That's why I have to place to here in the first cluster only. Next one is the 6. 6 and next one is the what are the 2 different mean points? One is the 4 and next one is the 12. Right? Automatically 6 is very closer to the 4 than the 12. Right? That's why I have to place to 6. Automatically remaining all the elements. 9 is immediate neighbor for the 12. That's why I have to place it within the second cluster. Automatically remaining 16 is very nearest to 12 other than the 4. Automatically remaining all the data elements or data objects are placed within the cluster, right? After that, we have to do the summation of cluster 1 and cluster 2. We are getting some value, right? That's why here 2 plus 4 plus 6 by 3. And here how many elements are there? By 6. Total number of data objects. Summation of value of data objects by total number of data objects. Automatically we are getting 2 plus 4 plus 6 by 3. Automatically we have the value is 4. Here we are getting 17.8. Near value I am taking, that is the 18. Right? And next we have to take the another values. Right? Now what are the mean values here? One mean value is 4, next mean value is 18. Earlier one I have to randomly I picked one mean value is 4, next mean value is 2 for framing of 2 clusters. Instead of that, already after the first iteration, you have to generate a new mean values. Automatically, what are the mean value here? First mean value is 4, second mean value is 18. Okay, by using these mean values or maybe the centroids, we are framing the clusters. Right? Automatically, what are the closure points for the 4, 2, 4, 6, 9? Automatically remaining elements are 12, 16, 20, 24, 26. It will be placed within the K2. Right? After that, we have to do the summation of the cluster 1 and cluster 2. We are getting the 5.25 and next here we are getting the 19.6. Automatically, we have to round figured for the particular values 5 and 20, right? Now, what is the mean values here? The mean value is 5 and 20. Now, we have to take it as a mean value and 5 and 20, and we have to again first to cluster values closer to 5 and second cluster values closer to 16. Sorry, 20. Automatically what we are taken, we are framing the clusters, right? After in the third iteration, you are having what are the closest to points for the particular 5? 2, 4, 6, 9, 12. How can you say that 4 minus 12, what is the difference here? 4 minus 12 means 8, right? And next one is that 12 minus yes, girls. 12 minus 20, automatically you are getting the value is 8. That's why I have to place the 12 in the first cluster. And next one is the remaining all the elements I have to place within the second cluster. Again, I am doing the summation for the cluster 1 and cluster 2. We are getting the different mean values. So that is the 7 and 22. That means when we have to end up this iteration, if you are doing the number of iteration, once when will we have to stop the particular iterations? You're not getting you're getting the same mean values, means at the time only you have to stop the particular repetition of the iterations. Here we can observe that this is the first one, first iteration, second iteration, third iteration, fourth iteration. You are repeating 4 times. When we have to compare the third and fourth time, you are getting the same values. Mean values are same. Here 7 and here 25. It's need not to repeat the again with the same mean value for framing of the clusters. If you are doing the number of iteration, it will not changing the value of mean value. Automatically, immediately you have to stop for doing of iteration for the summation of all the objects for finding of the mean values. Automatically, what is that? After doing of after the fourth iteration, automatically it will be stopped. Why? Because the third and fourth iteration having the same mean values. I stopped and I'm finalizing. These are the different kinds of the 2 clusters. Cluster 1 having the 2, 4, 6, 9, 12. Cluster 2 having the 16, 20, 24, 26. Initially, what are the values taken for the cluster 1 and cluster 2? 2, 4, 6. And second cluster is 9, 12, 16, 20, 24, 26. But here, after done the so many iteration, after doing of so many iterations, we have to changing of the cluster objects, group of objects. Finally, you are saying that 2, 4, 6, 9, 12 having the similarity is there. 16, 20, 24, 26 having the another similarity or the dissimilarity compared to the cluster 1. Finally, we are saying that based on the centroids, we are calculating the mean values and we are doing the number of iterations. Once you are getting the same mean values, so these are, we call it as a mean values. So based on the mean values only, we are doing the iterations. Finally, once you reach it to the same mean value, means you have to stop it. That is the k-mean algorithm, right? Now, tell me what is the overall k-mean algorithm? We have the number of data points, right? And next one is the out of the data points, we have to take the any 2 mean values or maybe the 3 mean values. That is your wish. If you have to take in 3 mean values, 3 mean values, automatically you have to frame the 3 clusters, right? Automatically, we have to first you are taking mean values from the data set only. After that, you are generating the mean values, right? And next one is the based on the mean values only, we are finding the nearest number of means and we have to place it within the cluster. And next one is the cluster 1, cluster 2, cluster 3. This process will repeat a number of times until we will get the same mean. Any more doubts in the k-mean algorithm? Very, very important. Any more doubts?
No, ma'am.
Is it clear?
Yes, ma'am.
Okay. Okay. Now, what are the advantages and disadvantages of the k-mean algorithm? It's very easy to understand, implement. Why? Because randomly we are choosing the mean values and we are calculating next meaning values, and we are identifying the what are the number of clusters. We are framing of the clusters based on the k-mean value only, right? That's why we can easily implement, and everyone can easily understand how to identify the k-mean values on the group of clusters. Okay, and next we can go for the what are the main drawbacks here. Only one drawback is there for the k-mean algorithm. It is very sensitive to outliers and rescaling concepts. That's why we have to overcome the problem of outliers. We should use the another algorithm is there, that is the k-medoids algorithm. Okay, inside the partition algorithm only you are having the another algorithm is there, that is we call it as a form algorithm. Form, PAM. Okay, PAM means partitioning around medoids. Okay, we call it as a k-medoids algorithm. The other name we call it as a form algorithm, right? What are the drawbacks? What are the allegates? What are the defects of the particular k-mean algorithm? At the particular computation time, it can be overcome by using of the form algorithm. Girls, can I play the one video for the k-medoid algorithm? Shall I play one video?
Yes, ma'am.
Girls, if you have any doubts, please ask me. It's visible?
Yes, ma'am.
Okay.
Effect of outliers that is actually present in case of the k-means algorithm, and this algorithm is proposed by Kaufman and Rousey in the year 1987, and the algorithm is also known as partitioning around medoids. Actually, we are instead of considering the mean or the center of the cluster centers, so we use what we call it as the medoids. So that's how the algorithm is known as partitioning around medoids. So we are basically partitioning the data around the medoids. That's how it's named as partitioning around medoids. Let's see how the algorithm works. So this is the basic principle of the k-means clustering. In case of the k-means clustering algorithm, given the input data, always if this is the cluster, then the cluster center, so the cluster representative, in case any cluster is represented with any cluster is having a representative point. In case of the k-means algorithm, this is the cluster representation, right, which is not one of the given data sample. So it is actually present in the cluster. So it need not to be one of the data samples because we are considering the mean of the data samples. Whereas in case of the k-medoids algorithm, when we go for the k-medoids algorithm, the data samples. That is the basic difference between k-means and the k-medoids. Other than that, both work more or less in the similar lines. So the basic working principle of the k-medoids algorithm is, instead of considering the center as a cluster representative, in k-medoids we consider one of the object of the input data or one of the object present in the cluster as the representative member for the cluster. So that is the difference between k-means and the k-medoids algorithm. And the simply as a medoid itself. So if you consider this cluster, and these are all the data points that are present in this cluster, in case of the k-means clustering algorithm, so the cluster is represented with the mean, and the mean need not to be one of the data samples. Whereas in case of the k-medoid, it is expected that one of the data points, either this could be the medoid or this could be the medoid, this could be the medoid. But it is not other than the medoid or the cluster representative is not other than one of the data samples. If you observe the problem limitation with the k-means clustering, k-means is very much sensitive to the noise, and this kind of cluster formation is only because of the presence of this outlier And as we are allowing the mean as a cluster representative, and which is not the one of the data object, and if we don't allow such thing, so this kind of clusters would not have been formed. So that is how we insist that the cluster representative must be one of the data sample in case of k-medoids. And now let's see the algorithm, how the k-medoids algorithm works. So we select k random points similar to the k-means clustering. We select k data points from the input data as the initial medoids. So now let's see how the k-medoids algorithm works. The working of the k-medoids algorithm. Similar to the k-means clustering algorithm, in k-medoids also, you need to select k random samples from the input data. And these k random samples of the input data, they act as the initial medoids in the algorithm. So now once you have the k-medoids, which are randomly selected samples, and we need data point in the data set to the closest medoid, and to assign every data point to the medoid, we can use one of the distance measures, and this distance measure can be any of the commonly used distance measure, and you can choose any of the measure depending on the type of the data you are using, or depending on the application you are using. And once that is done, the initial assignment of every data point to one of the closest medoid, we need to repeat this set of steps for a certain number of steps, and as long as the cost is reduced, you need to repeat this process. When the cost is not reduced over the iterations, at that point of time, we can stop repeating the iterations. And what we need to do in every iteration is, you have to select one of the medoid, so that you call it as M, and you choose one of the random data point O, and which is not a non-medoid, and you just swap M and O. That is, so you are making one of the non-medoid as a medoid, and you associate every data point and compute the cost. So once the cost is computed, you just check whether the cost is reduced by this reassignment or not. And if the cost is reduced, then you proceed with the swapping of the medoid M and the data point O. That is, hereafter, this data point O will act as a new medoid in your one of the k-medoids. Otherwise, if the cost is not reduced, then you just swap the M and O. That is, your M itself will act as a medoid, O will not be the medoid for your algorithm. And you need to repeat this process till the cost is reduced. And now let's see an example of k-medoids. How do we execute the k-medoids algorithm? So consider these set of examples. I have 10 examples, these 10 samples, and every sample is having two attributes. It is represented as x1, x2. Say for example, the first data point is represented with 7, 6, and second data point 2, 6, so on and so forth. So these are the set of data points that are given to us. And we are assuming that the k value is 2. That is, we need to select 2 of the samples as the medoids, the initial medoids, and assume that we are selecting 3, 4 and 7, 4 as 2 medoids. So similar to the k-means clustering, however, we did in case of the k-means clustering, in case of the PAM or the partitioning around medoids or the k-medoids algorithm, we are going to choose k random samples from the given data. And in this example, I'm going to choose this data point as the first medoid and 7, 4, and that is this one. So this is another cluster center, that is a medoid. So these two will act as a medoids for the algorithm. And let's try to assume that Manhattan distance is a metric that I'm going to use as a distance measure. So because we need to assign every sample to one of the closest medoid. So you need to assign this sample to either of these two medoids. Similarly, you need to assign all these 10 samples to one of these two medoids, right? And for that process, to assign every data point to one of the closest medoid, you need to identify the distance measure. And to make it simple, I am choosing Manhattan distance, because calculating Manhattan distance is very, very simple compared to the other distance measures. And now let's assume that we are going to identify the Manhattan distance. So now let's see, identify given sample is 7, 6. So this sample is 7, 6. And the first cluster C1 is represented with 3, 4 is the first medoid. And the second cluster is 7, 4. 3, 4 and 7, 4 are the two medoids that we are selecting. So once these two are selected, you need to assign this to either to the first medoid or to the second medoid. And for that, we are going to use the Manhattan distance as a distance measure. So let's compute the distance between 7, 6 and 3, 4. So the distance between 7, 6 and 3, 4. So how do you compute? Manhattan distance is simply the summation over the absolute distance between the corresponding elements. The summation of the absolute distances between the corresponding elements. So 7 minus 3 absolute value plus 6 minus 4 its absolute value. And what is it? It is 7 minus 3, it is 4 plus 2. So this is 6. So the distance between these 2 points is 6. The Manhattan distance is. Similarly, you need to find the distance between 7, 6 and 7, 4 also. And if you find the distance between 7, 6 and 7, 4, so the distance value is 2. So this is the distance from 7, 6 to the first cluster is 6. And distance from 7, 6 to 7, 4 is 2. So these two are the distances I got. And to which medoid I need to assign the first data sample? It is to the second medoid. So that is because the distance to the second medoid is less, we need to assign it to the second medoid. And now let's see. So here, these are all the distances I computed to the medoids. So for every data point, I just computed the distances 6, 2, and for the second sample, it is 3 and 7, and third sample, it is 4 and 8, so on and so forth. That is how I computed the distance to every medoid. So now once the distances are measured, you need to assign, depending on the distance measure, you need to assign the samples to one of the medoid. So first sample to which cluster to which medoid I need to assign, that is to the second cluster. The reason is simple. So because the distance is low to the second cluster, second medoid, you just assign the sample to the second medoid. And here, the second sample is assigned to C1, that is the first medoid. Then here, first medoid. Here it is second medoid. The next sample, of course, it's already a medoid and it's representing the second medoid. So assigned to the second medoid itself. And this one to the first medoid, the second medoid, and this is also to the second medoid, the second medoid, and of course, this is the first medoid itself. So that's how you just assign every object to one of the medoids. One of the two medoids. So the assignment is done. So once this is done, so you can observe that the clusters that are formed at this iteration, at this stage are, so you can observe this. So this is C1, that is the second object, 2, 6, then 8, 5, and 7, 4, and you have 6, 2, then 7, 3, 6, 4. So these are all the data points that form one cluster. And these are all the other points that are in the other cluster, that is cluster 1. So cluster 1 and cluster 2 are formed. So the initial cluster formation is over. Every data sample is assigned to one of the medoids. And now after this, you need to compute the cost. So with this assignment, so what is the cost that is involved? That you need to identify. How do we identify that cost? So the cost can be identified as, so the cost you can identify it as sum of the distances from the non-selected data points to the selected data points. So that value, the summation of that value will become your cost, the total cost. Now let's see. So here, because of this assignment of the first data point 7, 6, so because of the assignment of the first object to the second cluster, the cost involved. What is the distance to the distance from this object to the second cluster? It is 2 points, right? So you just consider the value 2, and I think I better use this 2 plus the second object. When you consider the second object, to which cluster you need to assign you assigned it the cluster 1 itself. And what is the distance? It is 3. So it's plus 3, and it's simply you can figure it out like this. So it's a minimum of the distances between the clusters. Minimum of the distances between the data points and the clusters assigned. That's how you can simply take the distances. Here it is 4 plus 2 plus 0 plus 4 plus 3 plus 1 plus 1 plus 0. So if you just sum up all these things, the cost is 20. And this is the cost that is incurred because of this assignment. And now let's proceed and do the swapping. The next step in the algorithm is you need to swap the medoid, one of the medoid. So you just select one of the medoid and swap that with one of the non-medoid. And I'm going to choose the 7-4 medoid. And instead of that medoid, I'm going to choose the non-medoid as 7-4. So now this is the non-medoid and I'm going to choose this as the medoid. So instead of that 7-4, I'm going to choose 7-3. And because of that, what is the cost that is incurred? Again, you need to repeat the process. So the same way, however, we did. So when 3 and now the medoids are 3, 4 and 7, 3. And because of this medoids, what is the cost that is incurred? So that we need to calculate. So the process is the same. So you just identify the distance measures from every non-medoid points to these two medoids, both the medoid points, and then assign every object to one of these medoids and then compute the cost. And because of this assignment, the cost incurred is 22. And what was the earlier cost? It is 20. So is the cost is reduced or increased? It is increased. Because the cost is increased, this swapping of the medoids is not a wise decision. So better don't use the 7-3 as a medoid, retain 7-4 as a medoid itself. Because the cost is not reduced, you can stop the process.
Yes, girls. Now tell me, what is the K-medoid algorithm? Yes. K-medoids clustering. Am I audible?
Yes, ma'am.
Now tell me, what is the K-medoids algorithm? What is the other name for the K-medoids? That is the partitioning around medoids, right? And next one is here we are choosing the randomly, you are choosing some of the points as a medoids, right? And based on the associate each data point to the closest to medoids using any common distance measure. Within the example, they have to take in the Manhattan distance algorithm. What is the Manhattan distance algorithm here? That is the summation of absolute difference between two data points, right? After that, we are finding the distance to, based on the medoids, we have to calculate the framing of cluster 1 and cluster 2. Then they have to calculate the cost. If the cost it will be increased, it's not need to swap the another medoid, right? If the cost is decreased, means we can go for the swapping of previous data medoids with the another data points, that is the closest medoids. In this way, we have to computing of the cost, right? If the total cost is more than the previous step, automatically we have to undo the swap. These are the steps for the K-medoids algorithm. See here how they are framing up partitional clustering. Already within the K-mean algorithm, you are choosing as a centroid points. Centroids depends on your clusters. Here we have to take in two clusters. So that's why we are choosing as a two mean values, right? And next one is we have to repeat the process until you get the same mean value compared to the previous steps, and immediately you have to stop with your process. Otherwise, within the second method is the K-meanoid. Other than the mean value, we have to take it as any centroid, any one point as a centroid. Based on the medoids, we have to find out the nearest points, and finally you have to calculate the cost. If the cost is decreasing, means you can go for swapping of new medoids. In case cost is increasing, means need not to swap the previous medoids. That is the intention for the partitioning algorithm. Next clustering method is hierarchical clustering. In the hierarchical clustering method, when we have to given any set of the particular objects of the data is created into the kind of hierarchical decomposition, right? And next one is the here we have the two approaches are there. One is the divisive approach and second one is the agglomerative approach. Okay, here we can observe that these are the different kinds of the points are there on the screen. Observe that they have to red color. We call it as a first cluster, second cluster, third cluster, fourth cluster, fifth cluster. What is the main intention for the hierarchical method? You have to start the cluster which are very similar to each other are grouped into the larger cluster. First, we have to find out what is the closest cluster. We have to frame it as a small clusters. Then only you will have to combine all the clusters together as a one cluster. That means large clusters may be further be grouped into the still large clusters, right? Here we can observe that without clusters, we have the points are 1, 3, 5, 2, 4, 6. These are the points, right? And I'm checking. You have to come from the top to bottom or the bottom to top. That is your wish. When we have to check the 6 and 4, 6 and 4, and 4 and 5, automatically 6 is very farther to 4. Very closure point is 5. That's why which one is the closure for the 5? Automatically 2 is the closure. It is very closure for the 5 other than the 4. That's why I have to frame the cluster here. And next one we have to check that 4 is closer to 1, 3 or maybe the 5, 2. Automatically 4 is very closer to the 5, 2 cluster. That is the cluster 2, right? That's why what we are doing within the hierarchical cluster, first you are taking nearest points making as a one clusters. After that, we are adding the next to closest points, and finally you are making as a single cluster, right? Within the fifth cluster, that is we are finally we are that means we are combined all 6 points or 6 data points together as a within a overall 5 clusters, right? First cluster is the nearest points. 1, 3 is the first cluster. That is the hierarchy. Within the hierarchy means we have to start it from the root node. That is the next to nearest node, next to nearest node, next to nearest node. Finally, you have to reach the end of the point. That is the leaf level, right? That is the same procedure here also. Which one is very closer? Those points together we have to make it as a small clusters, right? And next one, what are the approaches related for the hierarchical cluster here? One is the agglomerative approach. Second one is the divisive approach, right? And next one is the within this example. First example is the hierarchical cluster. This diagram is related for the hierarchical clustering. Second diagram we call it as a dendrogram. We have to convert it the same cluster, form it into the dendrogram. What are the points are there here? We can observe that 1, 3, 5, 2, 4, 6. Same thing here also repeated. 1, 3, 2, 5, 4, 6. 1, 3 I framed as a one cluster, and 2, 5 I'm making as another cluster. And next one is the 2, 5 as along with 4. And next one is 1, 3 along with 2, 5, 4. Finally, I have to mix up 1, 3, 2, 5, 4 along with 6. That means cluster 1, cluster 2, cluster 3, cluster 4, cluster 5. That means out of 5 clusters, I have to cover all the data points on the data space. This is the example for the hierarchical methods. Okay. What is that meaning here? Within the example, how many data points? X1 having the one data set, X2 having the one data set, X3 having the one data set, X4 having the one data. That is your wish. Depends on the particular representation of the values. We have to find out the closeness between the data points. Automatically depends on the closeness, depends on the similarity, nearest points. We have to make it as a one cluster. Finally, you have to cover all the points together as a single clusters, right? And next we can go for the next. What are the approaches here? Yes, we have the two types of hierarchical clustering is there. One is the agglomerative and second one is the divisive. Both are same, but we are following the approaches are the different, right? And agglomerative, it will follows top down approach. Divisive, it will follows bottom to top approach. What is the agglomerative approach? Agglomerative starts with points as individual clusters, individual points as a clusters, and each step we have to match the closest to face of the cluster until only one cluster left. This is the example. Just what we have to see in within the hierarchical clustering. This is the example for the agglomerative approach. Second one is the divisive approach. Within the divisive approach, start with one all inclusive clusters. Already we framed the cluster. We have to divide it as individual cluster. Here we are doing the splitting. In the agglomerative, you are doing the merging. We have the two differences are there. In the agglomerative, we are using the merging of closest pairs of clusters until one cluster is left. Earlier within the example, we have to see that is the combining of all the clusters together as a single cluster. That is, we call it as a first we are framing this small mini cluster, next to mini cluster, next I am combining what is the closest point, third cluster. Now I am combining fourth cluster. Next finally I have to combine the sixth data point as within the fifth cluster, right? That's why here we have to start it with the what are the closest points. We have to make it as individual clusters and we have to merge it up what are the closest pairs of the clusters. Finally, we have to end up the cluster with only one cluster. Second one is the splitting, opposite of the agglomerative approach. Automatically here we have to do the already we have the overall one cluster is there. On the one cluster we have to do the splittings until individual clusters, individual points, once we have to reach it within the particular space. That is the difference between the agglomerative and next one is the divisive approaches, right? And next one is that these agglomerative and divisive approaches also completely dependent on the distance, right? When we have to find out the closest points near to the so-and-so point, based on that only we have to frame the clusters. Here we can observe that the algorithm steps. First one is we have to how to calculate the distance by using up the proximity matrix. And second point, let each data point be a cluster. Individual first one as if one cluster. What is the closest point? 2 is 3 is closure. I have to make it as 1 3 as a one cluster. This one we have to repeat until merging of number of closest clusters. Once you finished, once you have to end up with the single clusters remains on the particular data space. See here, this is the example. These are the individual data points on the proximity matrix. Total points are the P1 to P12, right? Here I'm making as a cluster one. This one is one cluster, 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 and this one as a one cluster, right? That's why here it will be showing C1, C2, C3, C4, C5. Right, based on the proximity matrix, we have to calculate the distance between the points, and I am framing as a clusters 5. Next one, after individual clusters are done, you are covered all the data points. Now we have to merge the closest any two closest clusters. That's why if you can compare with the C2 is closer than C1. Sorry, C2 is closer than C1. When we have to compare the distance between C1 and C2, C5, automatically C2 is very closer to C5 than C1. Automatically, what I'm doing here, I'm making as a one cluster together. Now, instead of C2 union C5 as a single cluster, right? Here we can observe that within the example C2 union C5. Earlier you are having the 5 clusters, now you are having the 4 clusters. Next, you have to update the proximity matrix, right? Finally, what I'm doing, C2 union C5, it will be comparing the closeness either C1 or C4. Automatically C1 is closure. Now I have to combine as C1 union C2 union C5. Automatically, that is the second iteration. Next, you can go for the third iteration, whether C1 union, C2 union, C3, C5. Which one is closure? Either C3 or C4. Automatically, C3 is closure. I have to make it as a next cluster. Finally, we have to merge with the C4. Finally, we have to make it as a C1, C2, C3, C4, C5 as a single clusters. Okay. Next, how to define the interclustering distances? Closeness. That's why I said just now how to frame the clusters within the hierarchical. We have to make it as a single cluster by using of the minimum distance and maximum distance, group average, the distance between centroids. Other methods divided by an objective functions. That is, we call it as a Watt functions. By using these different kinds of the measures, we can use it, and we have to calculate the distance between different kinds of the clusters. Okay, that means this is one cluster, this one is the another cluster. How to combine these clusters? We have to check the similarity. When the similarity is there, immediately we have to check that whether what are the minimum points, what are the maximum point, what is the group average point. Now we have to check that what is the first measure here, minimum. We are out of these 4 points and second cluster points, which one is closure? We have to calculate the distance. Finally, these 2 points having the minimum distance from the cluster 1 to cluster 2. In this way, we have to calculate the minimum distance. Next, we can go for the maximum distance. When we have to compare these 2 points, these 2 points, these 2 points, and these 2 points, this one, these 2 points having the maximum distance. They have to calculate the maximum distance compared to the remaining data points within between 2 different clusters. Next one is the group average. We are calculating the group average between the data points from the one cluster to the next clusters. See that this is the example. We have to from 1 point to all the data points. From 1 point to all the data points. We have to taking the average from 1 point with the remaining all the points within the clusters. That's why we have to getting off just like a mesh. Next, we can go for the distance between the centroids, right? We are taking as a centroid, that is the artificial centroid I'm taking, and I have to calculate the distance between the 2 different clusters. Okay. Next, I'll show the example here. These are the comparison of all the measures related for the hierarchical clustering. We have the points are there, 1 to 6 points are there by using of different methods, measures, minimum, maximum, group average, and Watt methods. Now, how they have to design by using of all these measures here. Observe that 3-6 as first cluster by using of the Watt method. 3-6. 3-6, 3-6. These are very closure. Next to 5-2, 5-2, 5-2, 5-2. Here along with 4. Not with 4, with the other minimum distance, maximum distance, minimum distance. It will be changing. It depends on the measures, either minimum, maximum, group average, and Watt number. Finally, you are getting only 5 clusters only. Depends on taking of distance, either minimum distance or the maximum distance. Automatically, it will be varying. This is the overall comparison for all the measures related for the hierarchical clusters for framing of single clusters. Finally, you are getting the 5 iterations only. But you are taking the minimum value, maximum value, group average value, and distance of particular centroids. Okay. Finally, within the hierarchical method, we have to find out the closeness of the points. Based on the closeness, we have to cover all the points together as a single cluster. Within the hierarchical clustering, either we can use the 2 different methods, either divisive approach or maybe the agglomerative approach. Agglomerative will follow the bottom-up approach. Divisive will follow the top-down approach. One thing it will be follows merging, and second one is splitting. Okay. We have to calculate the distance between the clusters by using of minimum, measures, maximum, average, group average, and next one is the artificial centroids. It's clear, girls. Second method, hierarchical clustering. Hello.
Yes, ma'am.
Okay. Next, third clustering approach is the density-based clustering. Actually, here we have to calculate the radius. We have to divide it as a different kinds of the regions. We are avoiding of high density. Based on the radius calculation, we have to identify the what is the neighborhood value. Okay, and here we can observe that one of the approach for the density based method is dbScan, and dbScan is one of the best algorithm for density based algorithm. Here we can observe that we are identifying three different kinds of the points. One is the core point, second one is the border point, third one is the noisy point. Depends on your how much radius we have to identified within the circles, within the clusters, right? And what is the meaning of density here? Number of points within a specified radius. I have to assign specified some radius. Within the radius, how many points are covered? Those points we call it as a density, right? Now we have to check that within the example. This is the example for core, border, and noisy points. Observe that epsilon. We have to take it at within the epsilon. We are identifying a total number of minimum points. For example, if we can take it as what is the meaning of core point here? The core point means already I have to given minimum points are 7. Minimum points are 7. Which cluster it will be satisfying? It will be within the radius for covering of all the 7 points. For example, if you can check that this is the one cluster, and this one is the second cluster, and this one is the third cluster, right? Out of this, I am taking as this one as a EPS, that is the radius. Within the radius, I have to cover this whole cluster, and we can find out the total number of points within the particular circle. 1, 2, 3, 4, 5, 6, and 7. That means minimum points are 7. It will be satisfying of core point. That's why I have to take in this cluster having the core points. For example, if you can go for the second cluster, we can identify that how many points are here. 1, 2, 3, 4. Only 4. It will not satisfying of minimum point 7. Okay, 4 is less than 7. That's why we can't call it this cluster having the core points. Right? And next one is the third cluster. 1, 2, 3. Only 3 points are there. It doesn't have the minimum 0.7. That's why we can't call it this one as a core points. Only first cluster having the core points. Neighborhood contains at least mu data points within the given radius, right? And next one is the out of clusters. What are the points are left? These we call it as noisy points are the outliers. Right? We can easily identify that which points are the noisy points. And what is the second one here? Border points. What are the border points? Which points are attached to the particular borders of the clusters? We call it as those are the border points. So that's why this is the border point, this one is the border point, and only 2. This one is the border point, this one is the border points. Okay? This is the original points. I'm taking the minimum points are 4 and epsilon is 10 within the radius. I have to cover 4 data points. Finally, what is the meaning of dbScan algorithm? We have to data space is there. We have the different kinds of the data points are there. We have to label it after framing of the clusters. We have to label it which are the core points, which are the border points, which are the noisy point. In case noisy points are there, automatically you have to eliminate it without a disturbance. Now we have to calculated the distance between all the core points by using of the epsilon within the radius only, whether it will be satisfying the epsilon value or not. That is the minimum points, right? We can easily identify which cluster having the minimum number of points related for the core, right? And those clusters we have to make it as a separate, and remaining all the clusters we have to treat it as either border points or maybe the noisy points. Observe that here. Okay, last topic, outlier detection. Just now we have to all the data, all the algorithms related either partitioning or maybe the hierarchical algorithm or maybe the density based algorithm. What is the main issue related for that? The particular algorithm is sensitive for the outliers, and it will maximum you are avoiding of outliers by using of the algorithms only, right? Here we can observe that main outliers means what are the problems you are facing in the real world only. Outlier detection is a natural extension of data mining techniques. While data mining is the extraction of when we are doing of any kind of the patterns or the trends in the data set, we are identifying of, we are discovering of outlier detection from the general patterns or the general trends, right? That's why what we are doing here by using of different kinds of the approaches. First, we have to detect the outliers, right? Here we can observe that how to identify the outliers, what are the features of the data objects, whether the similarity, if the dissimilarity means that is the outlier, and it will be having the noise within the particular data set. Automatically we can treat it, those data points are the outliers. Here we can observe that we have three types of outliers are there. One is the global, and second one is the contextual, third one is the collective outliers. I think they have to give in the clarity for how can you identify the outliers within the group of elements, right? The particular outlier, it will give us some disturbance or deviates the other data points within the particular data set. When I'm taking the class within the classroom, how can you identify who are disturbing the class? If any person is doing any other work, or maybe if the person is talking, if the particular student is talking or doing another things, automatically it will deviates the what the faculty are teaching, right? We can easily identify that the person is not interested to learn anything from the faculty. The person, we call it as just like an outlier. The outlier, the student, it will deviates the topic. It will be giving the some disturbance within the particular classroom, right? That's why here this is we can easily identify the globally when we are having the multiple data sets with followed by the data points also. If we have any deviation is there, we can easily identify the outlier object. Contextual outlier objects, for example, we have the different kinds of the seasons are there, right? The particular depends on the season. In the summer, what is your extreme temperature? What is the lowest temperature? We can easily guess it, right? That's why in case if the maximum temperature is 30 and 35 and lowest temperature within the summer is 25 means actually the values can be vary from the 25 centigrades to 30. Automatically instead of 25, in case if you are having the 1 or 2 temperature mean auto it is outlier. right? This is the within the context. It is this particular temperature value is the deviating of overall context. That's why we can easily identify that which one is the outlier temperature in the overall month. Daily we are calculating the temperature for the day, right? Automatically if any deviation is there in the so in the because of some reasons it will be deviating the so and so temperature on the of the particular day, right? That's why what we are doing here, we have to how to identify that particular outlier object. It depends on the context. That is the summer season. We have to check the time, we have to check the location, why it will be varying the temperatures. If it will be varying because of the reasons this temperature is very low within the so and so location, automatically we can say that this is the outlier object other than the other locations, other timings, right? Automatically, how can you identify this outlier object behavior? That is the characteristics, right? We can evaluate, depends on the numbering of the temperature, degrees, right? And next one is the collective outliers here. A subset of data objects collectively deviate significantly from the whole data set, even if the individual data objects may not be outliers. Sometimes we can't, sometimes it will deviate, not whole group, it will deviate from the subset of the, just now we have to discuss about the hierarchical clustering. The disturbance we formed 5 clusters, right? It will not disturbing all 5 clusters not at the same time. Why? Because it will be framing as individual clusters. Those are for 1 cluster, 2 cluster, 3 cluster, 4 cluster, 5 cluster. These are all the subsets. Overall, you are having the 5 clusters. Out of this, we are having the 1 cluster, that is the 1 subset, 2 subset, 3 subset, and 4 subset. We can easily identify that if you have any disturbance or the deviating of the environment of the clusters, automatically we can identify that those are the collective outliers within the overall data set, right? And next one is statistical outlier analysis. Based on the statistics nature, we can identify the objects for the particular lower probability regions of the model as a outliers. We have the 2 kinds of parameters are there. One is the parametric, second one is the non-parametric methods. Okay. Okay, thank you, girls. Yes, girls, any more doubts? Finally, I have to given the clarity for overall briefing of clustering concept. What is a cluster? What is the main advantage for defining of clusters in the applications? And next one is what are the characteristics of clustering? What are the types of clustering with followed by the algorithms, right? What is the meaning of outlier? Can I leave, girls?
Thank you, ma'am. Pushpa, ma'am.
Okay, thank you,
for
ma'am.
accepting our invitation and presenting our students.
Okay, thank you, ma'am. I'm leaving, ma'am.
A vote of thanks. Yes, Divya, vote of thanks. 1 minute, ma'am.
Yes, ma'am. Yes, ma'am.
Yes, do it.
On behalf of my class, I extend a really hearty vote of thanks to our guest lecturer who spared time from her busiest schedule to grace the occasion today. Today, we had an opportunity to hear your thoughts, and this will surely be going to encourage us in our future events. I'm immensely thankful to Mrs. Pushpalata for her effort towards lecture of today. Her own ideas and elegance of explanation of everything. I need to mention my deepest sense of appreciation. I also extend thanks to all the staff members of our department for organizing of this lecture. Thank you so much. Thank you so much, ma'am.
Thank you.
Yeah, thank you. Thank you, ma'am. Thank you, one and all students.